We're looking at number 37 on page 216. The question asks us to use the second derivative test to find the extreme values, maxes and mins, of the function y equals x times e to the x. So let's remember what the second derivative test says. The second derivative test says that if f prime at some value, we'll call it c, equals 0, and f double prime, the second derivative at that same value of x, is less than 0, so it's concave down, then we get a max at x equals c. The second derivative test also says if f prime equals 0 and f double prime is positive, in other words, it's concave up, that's going to be a min. That's what the second derivative test says. It doesn't tell us what happens if f prime is not equal to 0 or it's undefined, and it doesn't tell us what happens if f double prime equals 0 or is undefined. But if f prime, if the first derivative is 0 and the second derivative exists and is not equal to 0, then we can determine whether it's a min or a max. Okay, so let's apply that to this. Here's our function. Our first derivative is going to be, using the product rule, e to the x plus x times e to the x. The second derivative then will be e to the x plus e to the x plus x e to the x. Use the product rule to get to the first derivative, then the second derivative. This e to the x just became an e to the x. This x times e to the x broke apart according to the product rule again into those two terms. This can be simplified into 2 e to the x plus x e to the x. Okay, so let's see. We want the first derivative to equal 0 for the second derivative test. So we're going to take the first derivative and set it equal to 0. E to the x plus x times e to the x equals 0. Now let's factor out the common term. They both have an e to the x, and we get 1 plus x. This is great because we have two things multiplied together that equal 0. That means either e to the x equals 0 or 1 plus x equals 0. Well, e to the x, remember e is just a number. It's 2.7, 2.718 going on forever. So that to any power, never going to equal 0. Positive number, and we're raising it to a power. Nah, we're never going to get 0. We're never going to get a negative number. This can't happen. So that leaves our only solution as being 1 plus x equals 0, which means that x equals -1. So we're going to take that value, that's c, f prime of c equals 0, f prime of -1 equals 0. So now we check out what f double prime of that x value, f double prime of c. So we're going to say, what is f double prime of -1? and we're interested in whether it's a positive or negative number. So that's going to be 2e to the negative 1 plus negative 1 times e to the negative 1, which, let's get rid of those negative exponents, they're hard to think about, is 2 over e, then plus a negative 1, so that's minus 1 over e, which is just 1 over e. E is a positive number, so 1 over e is a positive number, and that gives us our answer. We have f double prime being positive, then this must be a minimum. Y has a minimum at x equals negative 1. What is that y value? Just plug negative 1 into the original function, and we find out that it's negative 1 over e. Negative 1 times e to the negative 1.